Hello everyone, welcome back to the channel. I hope you guys are doing pretty well. So let's see today's daily challenge on LeetCode and we will try to solve it together. So today's challenge is a pretty simple one, I will say. It's an easy medium kind of problem. Let's try to understand the problem statement at first. Maximum matrix sum. You are given an n cross n integer matrix. You can do the following operation any number of times. Choose any two adjacent elements of the matrix and multiply each of them by -1. Two elements are considered to be adjacent if and only if they share a common border. Okay, and your goal is to maximize the summation of all elements in the matrix. Return the maximum sum of the matrix elements using the operations mentioned above. So if you see this matrix 1 minus 1 minus 1 and 1, you want to maximize the sum of all elements in the matrix. So you'd see that some of the elements are now negative. So you would want to try to convert them to positive. Okay. So in one operation, what you can do, you can select the adjacent element and multiply each of them with -1. So you see, if you select these two elements in the first row, in this example 1, uh, and then multiply both of them by -1, you will have the first number to be -1 and the second number to be +1. Now you see both of this -1 comes into adjacent elements, so you can multiply both of them with -1 and you will get all positive numbers. Okay, and the result will be 4 because the sum of all the elements in the matrix, that is 4. Okay, so if you try to see this example also, you are able to convert the more negative number into positive numbers, and if there is only one element remaining, no matter how much you multiply or no matter how much operations you perform, you cannot convert that to a positive number. You cannot convert all the elements of the matrix to be positive. Okay, you can only shift the position of this -1 by multiplying with -1. Okay, so yeah, I hope that is very clear to you. And yeah, the constraints are pretty loose, n, so definitely n square, n cube, anything will do. But yeah, of course, n square is the optimal solution over here. You just need to traverse in the matrix once. So yeah, let's see the solution. I hope the solution might have been a little bit intuitive for this one. So let's see. First of all, let's consider that you have an even number of negative signs. Okay, even number of negative numbers. Okay, I hope you do understand what will happen in such a case. So let's say some negative number was there. This is a positive number, and negative number, negative, negative. Okay, so and remaining all the numbers are positive. So what you want to do is basically change all numbers to positive. So in case of even number of negative numbers, this is always possible. Why? You see, you can select these two numbers, whatever they are. Let's say they were -2 and +2 and -3. Okay, so you can just multiply both of them with minus. Okay, so what will you get? This sign will become positive and this sign will become a negative number. Okay, and now you have these negative numbers side by side. So what you can do, you can multiply, let's say, both of these negative numbers by -1 and -1, and both of them will become positive. Okay, so all these numbers now become positive. So yeah, similarly, if you uh, perform the operation on these two elements, this minus will become plus, this plus will become minus. Yeah, so that what happened, right? If there is 2 and -3, as I told you, if you multiply all by minus, this minus shifts. Okay, so you see that you are able to shift this minus sign to anywhere. Okay, and if you are able to shift it to anywhere, you can definitely bring it to the one where negative is there, and they will be side by side, and then you can make both of them again positive. And if two numbers, let's say -2 and -3, are negative, you can definitely multiply both of them with -1 to get a 2 and 3. Okay, so what do you get? What is your first observation from this? Okay, the observation which becomes very clear, that if there are even number of negative numbers, all can be converted to positive, because see, one negative number can be moved around. So if they can be moved around anywhere, you can bring it to the one where negative sign, another negative sign is there. So if there are even number of negative numbers, all can be converted to positive number. Okay, so in such a case, you see, in such a case, what will happen? Answer will be sum of all positive numbers. Okay, so an answer will be sum of all positive numbers. Now, not only positive, you see all the negative numbers which are there initially will also be added in this sum, right? Because so sum which will be calculated by plus equal to absolute value of this, let's say, matrix ij. Okay, I hope you do understand what I'm trying to say. uh, for every element of the matrix aij, I will calculate the absolute value, because hey, there are even number of negative numbers, all can be converted to positive, so all should be in my sum. Okay, so that's why I will take the absolute sum. And one thing is there, what if there is an odd number of negative numbers? So let's say one thing is very clear, that let's say there are 5 negative numbers. Okay, then you can get rid of 4 of them, because the 4 is an even number, so one negative number remains. Okay, by the same logic, see, by the first, whatever we draw a conclusion from the first one, by the same logic you can convert 5 negative number to 1 negative number. Okay, now this one negative number can be moved around all over the matrix, right? So let's say initially I have a -4, then we have 1 2 6 5 3 2 2 4. Okay, so let's say I have something like this configuration, like this. So what will you do in such a case? See, you can move this minus sign to anywhere, right? So if you multiply both of this becomes +4 and this becomes -5. Okay, so you would want to keep the next, since you want to keep the sum of all elements of the matrix to be the largest possible, you would want to place this negative sign to the place where there is the smallest absolute value. Okay, so if there was some number, let's say this was 2, and uh, let's say this was 1, or maybe anything. Okay, this is only 1. I would want to transfer my negative to the smallest absolute positive number. Okay, so yeah, smallest absolute number, you can say. So I would want to transfer my number to there. If what if there was 0, I could have multiplied both of them, this would become plus, and 0 minus will become 0. So this minus sign I would like to transfer to the place where there is the minimum absolute value. Okay, so for the second case, that there are odd number of positive numbers. Okay, you convert at the odd number of negative numbers, you convert that to one negative number, and then transfer the negative sign to the place where uh, minimum absolute value is present. Okay, I hope that will be very clear. Okay, uh, there should be no issues with this right now. So I hope if you think you can code this solution right now, you can just drop off from the video and try coding it on your own, because that will help you improve. Yeah, so let's see the solution. We have matrix dot size. It is an n cross n matrix. It's a square matrix, already told in the question. And what are all the things which we have? You see, I can have a long and have a sum. Here the absolute sum I will calculate. I also have a count, how many negative numbers are there in the matrix. Okay, and I will also have a minimum absolute value. Okay, minimum absolute value, I will initialize it with int max. Okay, because I want to calculate the minimum absolute value that will have the negative sign. If there are odd number of negative signs, then this minimum absolute value will have some value. Okay, so now you see one thing, what if how will you calculate the sum of all this? You got to know that you will make this positive and make this negative, but how will you calculate the sum? See, you have the absolute sum with you total right now, that is sum. Now minus, see, now the contribution of this minus 1 is actually +1, right? So 2 into this small number, 2 into this minimum absolute number. Okay, I hope you do get it. Don't just simply subtract it. Subtract it 2 into that many number of times, because yeah, contribution if changes from +1 to -1, it means that there is a jump of twice. Okay, so if contribution changes from plus x to minus x or minus x, then it is a change of 2x. Okay, if the contribution would have changed from plus x to 0, then the change would have been plus x. Okay, but since the contribution is changing from minus x plus x to minus x, the you would need to jump it twice. Okay, so sum minus 2 into minimum absolute sum. Okay, so yeah, I hope it is very clear, very simple, and we can just simply do the coding. The coding portion is always very easy, right? Once you understand the logic, mostly if it is not an implementation based. But yeah, in this case the coding is pretty straightforward. What I want to do, if matrix of ij is less than 0, I want to increase the count. Okay, I again want to do what is this minimum absolute sum. It will be nothing but minimum of minimum absolute sum comma this, not sum, minimum absolute number. Okay, so absolute value of matrix ij. Now we must make sure that this is of type long long. So this absolute matrix is of type integer. So you need to typecast it to long long. Don't forget to do that, otherwise there might be a type error. And minimum absolute we have also implemented the count. We need to find the absolute sum. Okay, so absolute sum is nothing but plus equals to absolute value of matrix. So you just convert everything to positive and just calculate the sum once. Okay, from that sum you just need to subtract the minimum absolute 2 times. Okay, so if you see, if the count of this modulo 2 is equal to 0, what would that mean? That would simply mean that, hey, you need to return this sum, because if there are even number of positives, okay, if there are even number of this sum, what you can do, if there are even number of negative numbers, you can convert all of them to positive and you need to simply return your absolute sum, total absolute sum. Okay, otherwise if this is not true, then it will the line will come to here and you can just simply write sum minus 2 into minimum absolute. I hope that is very simple and easy and not at all confusing. So let's try to understand by submitting if we need to take care of any more cases. You see, all the cases are actually being covered, so I hope this is the correct solution and this will work just fine. Let's see. Yeah, it just worked fine, and you see the time complexity is also not too much. Time complexity is I hope you can understand from it is n square, and if you need to traverse the matrix, at least n square you need to do, right? Although it is showing 6% here, but it varies a lot, and you do understand that for at least traversing the matrix once, so from 6 it became 32. So yeah, it varies a lot, but you do understand the time complexity is simply n square. I'm not using any extra space or anything, extra array or any extra computation. You see, is a simple n square solution. So yeah, I hope this will be very clear to you, and I hope the approach is also very clear. So yeah, that's all for this video. I will meet you in the next video. Till then, thanks a lot.